Hello, welcome to everyone. I'll just wait for a moment and see if any more people join us. And we'll start in one moment. Thank you. Okay. So thank you very much. I hope that you found the information and the material today, or up till now, interesting. And the idea of this session is to go through some of the solutions and portfolio that we have got in the area of final assembly. My name is Matthew Weir. I work based out of Barcelona, and I work in the team which is dedicated for the development of the solutions for the final assembly area in the automotive plants, truck and car. The solutions that we have got, actually, just hold on one moment, please. Sorry about that. So the solutions that we have got in this area are very much aligned with what we heard earlier from Volkswagen about the requirement to reduce the quantity of hours or time to produce the car. And we'll get into what we're looking at. So as we know, there is a revolution when it comes to the propulsion of the car with regards to electrical vehicles and hydrogen vehicles and solutions that are different from the traditional internal combustion engine. There's also a revolution which is going on in how to make the car with less person hours involved. And this is an area that ABB has invested in heavily over the last maybe 2 to 4 years, where we have been developing solutions to overcome the problems that we see in the manufacturing area. So if we look at a typical assembly line, what we see is that there is a small percentage of the tasks that are automated today. So in the order of less than 10%, perhaps 5% of the activities in a final assembly area are automated. And if we compare that with body in white, for instance, we see something in the order of 95%. So there's extremely high amounts of automation in one part of the car manufacturing process and a very low amount of automation in the final assembly area. And there are some reasons for that. So some of them are that we typically see in the car plants and the truck plants today that the bodies are in continuous motion, and they don't stop as they go from station to station. What comes about, or one of the results of that, is that there are vibrations and random movements in those car bodies. And something which is moving and something which is moving randomly is not something that a robot really likes to work with. It doesn't work very well. We also see that the operators often have ergonomically difficult or challenging tasks. And what we can see in this photograph, for instance, is that the operators here have their arms above their shoulders, and that from an ergonomic point of view is really not what we want to do. So all of this makes us see, as an automation supplier, we see that there's an opportunity here to provide some support that is aligned to the KPIs that the car manufacturers have got, which is basically improving the situation for the operators on the line, as well as reducing or improving the productivity. Just a bit of terminology as we go through this presentation. When we talk about stop and go, what we mean by that is that the car or truck stops and is stationary in front of the robot during the operation. So we typically have the conveying system, which will move and then stop in front of the robot, and there could be some type of centering device or holding device that keeps the car body stationary while the robot does whatever the action is. When we look at continuous mode, or we talk about continuous mode, we also use the terminology moving line. What we're referring to is that as the car bodies move from one station to the next station, they go continuously without stopping, so they're moving at a constant rate. And if we look at the words on the left-hand side in the grey boxes, we see that we have transportation, which is continuous, and in the box on the right, what means the line is moving continually. We need to track that movement. The target tracking and the robot guidance solution needs to be, has some challenges associated with it, and we need to absorb these movements. So continuous means that the object is moving and it comes with some technical complications. I forgot to mention earlier, there is a chat box at the on the right-hand side of the screen, and I will just put some words in there, and I very much encourage that people add questions or comments here. It makes things a little bit more active and interactive. And the other thing that I'm very interested in hearing is some feedback about what are the areas of interest for yourselves. What are the pain points? Is there something that you see that you like? Is there something that you would think that would be of use for you but is not in this presentation? So we can try and tailor things to meet your needs. So based on the scenario that we are working in the final trim area, ABB has developed some disruptive technology. We'll see a video of this in a moment. What we are looking at is, or what we will see, is a solution which ABB calls a dynamic assembly pack. And what this does is it's a combination of artificial vision and force feedback that acts as a sight and a feel, or emulates the sight and feel that we have as a human. We get the sight and the feel from a real-time camera and force sensor on the gripper. We can see this in action and when we have a look at this video. So what we will see is we are looking at, and I'll just pause the video for a moment, we're looking at a car body which is stationary and a robot which will place a door onto the hinges on the car body. The car body is being shaken, physically shaken by a person, and is really an exaggerated motion or an exaggerated example of what the car bodies do when they're moving on a continuous moving line. The robot needs to place the hinges onto the door, onto the hinges, and as the person is physically shaking the car, which is not an easy task to do. And what we see in this video is that in spite of the very severe movements and vibrations that the car body is going through, the robot is able to place the top and bottom pins onto the top and bottom hinges. Just repeat that again. So this is a very visual example of the capability of this technology. And here we are looking at placing doors onto hinges. The technology can be used for any application where we need to track a moving device and put something onto it, do something to it, take something off it. The dynamic assembly pack comes in 2 modules. We call the description of the dynamic assembly pack is that it's a compliant real-time vision solution which allows us to do assembly tasks on moving and unstable targets. So if you like, we can do things we can add or include or remove processes or equipment onto moving car bodies, moving truck bodies, etc. It comes in 2 modules. The first module, we call it UVT, or Universal Vision Tracking, and we'll go into a bit more detail in a moment. And this consists of a camera on the base axis of the robot. There is a second component, which we call Compliant Vision Guidance, or CVG, and this is located on the robot wrist. as well as on the robot gripper. So here we see the universal vision tracking module, where we have a camera on the base axis of the robot. The camera is looking at a marker on the car, in this case, or the skid. In this case, the marker is what we would call a QR code. And what we do is we have the camera observing the area that we need to observe, and when it sees the QR code, then the camera tracks it, and we move the conveyor, we move the axis 0 of the robot at the same speed as the conveyor. So if we have the car moving like this, and we have our robot moving at the same rate, or I should do it like that, maybe better, then what we see is that the robot has no relative motion compared to the movement of the car. The second module is the compliant vision guidance. And so what we have here is on the right-hand side, we can see an image or a photo of a gripper showing where we have a force sensor between the gripper and the robot, and a camera system on the right-hand side. And the camera system combined with the force sensor allows us to emulate the sight and the feel that a human has. We'll just have a quick look at how the vision system works. And here what we're looking at is an example of the vision system identifying a physical characteristic of a door. So at the moment we're having the lighting looking at the door, and we can see here blue circles. This is where the vision system is trying to identify a physical feature of the target. In this case, the target is a series of holes on the inner side of the door. When the blue circles turn white, this means that the vision system has captured the target and tracks the target. And we'll see that in a moment. So here we see that the vision system has identified the target and is tracking it. And when we have this white showing on the HMI, the screen, what this means is that the vision system is now going to send motion or position information to the robot, and it is the vision system which is guiding the robot. This vision system is a proprietary ABB development. There was nothing available on the market that we could use, and what we need is a very high frequency of position information. So we're taking 20 to 30 frames per second, and we are updating the position of the robot based on the position data that we're getting back from the vision system. And then as our vision system guides us into the correct position, we do any final fine adjustments using the force sensor. So how can we apply this? Well, we have this application. We're using this disruptive technology in the moving lines where we need to remove or add equipment to the cars or the trucks. So we have this for cockpit installation, for door assemblies and removals. For main wheels and spare wheels, we're using that in stop and go applications. We have here a mixture of whether it's movement or stop and go. So we do installation of all sorts of different parts of the car. We'd have a long and varied installed base with regards to priming or gluing, priming, sealing applications for windows. We do installations on mountings of carpets, seats, and grommet plug insertion. We do have solutions for marriaging and decking, and in quality control with flush and gap, as well as visual inspection. And here we can see and try and give a snapshot of which of those applications are in stop and go. The applications in stop and go are the ones that are marked with the octagonal symbol. So we have the glass installation gluing, the grommet plug insertion, tire mounting, and front end modules. And then we have some that are available in continuous mode which includes the cockpit installation, door removal, seat placement, and carpet placement. This is just a summary. It's not the full portfolio that we have got. So now I'm going to show a series of videos, which is the applications where we can see the solutions working. So the first one we have has a good example of the dynamic assembly pack, and in this case, this is the installation of a cockpit into a moving vehicle. I'll just stop here. The video here. So what we're looking at on the right-hand side of the image, we have a car which is on a dolly or a frame. It has wheels, and the car will move towards the camera on a chain conveyor. In the middle left of the screen, we see our robot, which is on a base axis track, a 7th axis track, has an orange gripper, and the gripper will pick up a cockpit or an instrument panel, which is on the left-hand side of the screen. So here, the cockpit gripper is fully automated. It is available for multiple models, not just for a single model running on the assembly line. And we see here what we saw previously, the force sensor on the left-hand side and the vision cameras on the right-hand side, making up the module of the compliant vision guidance. Here are 2 cameras and LED lights. The idea of the LED lights give us sufficient illumination in the area that we need the cameras to work, and we have 2 cameras so that we have a high uptime and we have redundancy. The gripper in this particular example has nut runners that remove the instrument panel from a carrier, and here we see the markers on the car body, similar to QR codes. Here we have the camera on the base axis of the robot, and as the car body goes past and the camera detects the QR code, it signals the base axis of the robot to move at the same speed that the car body is moving. So now we have, as far as the robot is concerned, a car that is sitting in front of the robot, but it's jiggling and wiggling a little bit. It's vibrating. Then, as we insert the cockpit into the car, we illuminate the area that we need to inspect. In this case, the physical feature that we will be tracking is part on the front quarter panel of the car, where we see the high intensity LED lights and the cameras, and they will start searching, tracking the car at a very high frequency. We then are able to place the cockpit into position based on the information from the cameras, and the final movements are absorbed. The final vibrations as we're putting it into the final position are absorbed using the force sensor between the robot and the gripper. So we have this in operation today in plants in Asia, Europe, and the United States. And this is, again, one of the applications, but this is not the only application for the dynamic assembly pack, the 2 components that we have in the dynamic assembly pack. Here we have a different application. In this case, it's the installation of seats, or the placement of seats into a car while the car is in motion. In this case, we are not using the QR code and the tracking for the conveyor. This is a slat conveyor, and we are using an encoder that tells the base axis, the 0 axis of the robot, the speed reference. So we're able to match the speed of the car using this information from the conveyor. The reason why we developed the other solution, not using a conveyor, was because with an AGV, obviously, there is nothing to track with an encoder. So we needed something which would be suitable for both conveyors as well as non-conveyor solutions, AGVs. In this application, we see that the robot then picks up the seat and is able to place it into the car. Here it is placement. We are not doing the installation. The reason is that the mechanics of the bolting and the electrical connections of the seat are very difficult for automation, and the product itself would need a design change to make it a viable option for automation. And there are some car manufacturers that are looking into that, but as of today, we are doing the placement of the seats, and a downstream operation will then need to do the connections of the mechanical and the electrical connections, the bolting and the electrical connections. Here we have the installation of, or the placement of, carpet into a car in motion. And what we've done is we've sped up some parts of the video just as the robot is moving around, not when the robot is doing the gripping operations, purely for this presentation, so that we don't spend a long time watching things which are not so interesting. So here, the main driver is the ergonomics. These carpets are heavy and cumbersome, and there are ergonomic problems when the operators need to work with them. So what we have developed is a solution to be able to place the carpet inside the car body, and then the operators in a downstream position or location would need to do the fine adjustment, which is not ergonomically difficult, and the fixing of the carpet into position. So here what we're doing is we're just checking the position of the car, we're tracking the position of the car, and we place the carpet into position. And it was a bit difficult to do the design of the gripper due to the space constraints. And in all of the cases, we have multiple, the design of the grippers and the solutions are for multiple car bodies, not just a single car body on the assembly line, of course. Here we see the removal of a door, and in this case we have the video is of a car body that is stationary, and we have done this video in our workshop in ABB. One of the most important things about the solutions for door removal is the hinge design. So in this case, we open the door and then we come in, and the hinge design here requires a pin to be removed, and we've got a number of different solutions for door removal based on the hinge design. So here we need to remove the pins, and then we do the removal of the door from after the pins have been released, and we place the door on the carrier that will then go off to the door assembly line. The gripper here is suitable for multiple variants and sizes of doors, so we are conscious that it needs to be suitable, the solutions need to be suitable for more than one car model. Here we have an example of grommet or plug placement, and what we see is that the robots here need to cover up the holes that are in the underbody of the car that are required as part of the paint process. So obviously after the car goes through the paint shop, it needs to have the holes that allow the fluids to come out of the painted body. We can see a lot of black marks, black holes in this image, and the robots go placing the plugs into the holes to cover them up, and there are multiple hole sizes and shapes and locations, and this cell is capable of that doing upwards of 90%, typically upwards of 90% of the holes. We have solutions there to get a single plug presented to the robot, and I will skip through a little bit on this part of the video. The robots have got multiple fingers to be able to pick up the different types of plugs, shapes and sizes of plugs, and they have two types of fingers. One set of fingers are stationary. That is not always suitable depending on the access into the car area. In this case, what we see is that we need, for access reasons, to have a pin or a finger which is extendable. What the robot is doing, and I'll go back one moment in the video, the robot is doing here is taking an image to identify the position of the hole to be plugged. It is inserting, so first it takes a shot, an image to locate the position. It inserts the plug and then takes a second image to ensure that the quality of the plug placement is correct. One of the areas where ABB has got a lot of experience and a very large installed base globally is with regards to glass gluing and glass installation. In this case, what we're looking at is the installation of the glass roofs on the Mercedes van, a large van, and we have on the video what we see is the glass after it's taken from the container. We need to center it so that we are able to do the next operation. So here we have a centering table, and after the centering table puts the glass into a known position, we're able to pick the glass up with the gripper, and then we clean the glass prior to the next step in the operation. The cleaning process consists of some fluid that is placed on some felt type material and cleans the area. We do not see it in this application. It wasn't needed for this particular project to have any priming. So here we're just cleaning, but the priming operation is really the same process after this one as well. After the cleaning is done, we need we let it rest, and we have a flash off time so that the cleaned area is dry and ready to go to the gluing operation. In this project, we did this over a summer shutdown, the installation, and there were many variants, and a lot of programming time was done, and we were working 24/7 to get this installed over the 3-week period that we had. Here we see that we apply glue, and there is a vision system on here on the glue applicator that does a quality control check to ensure that the shape and the volume is correct for our requirements. After the glue has been applied, we then present the glass ready for the car. And we will see in a moment that we do a position check of the car using another robot. So once the car is stationary, we get the exact position of the car using a separate robot using a 3D camera, and we identify the position of the hole in the car. And that robot then transfers the position information to the material handling robot, which then places the sunroof or places the glass into position. After the glass has been placed, we do a quality control check to ensure that the glass is correctly positioned. So we have solutions for this for front windshield, rear windshield, quarter glass, sunroofs, some commercial vehicles, heavy commercial vehicles, trucks, etc., installed in many locations globally. And the next application is the installation of tires, wheels. So here what we see are 4 robots that are doing the installation of wheels onto a car, and there is a 5th robot which is doing the installation of a spare wheel into the spare wheel well at the back of the car. The robots pick up, they fill the nut runners with the nuts, and then there is a vision system which identifies the rotation of the wheel on the conveyor. There is another vision system on the camera which is mounted on the robot gripper that identifies the location and orientation or rotation of the axle. Then the robot places the wheel into position, and the nut runners torque the nuts, or bolts, in this case nuts, as needed. We saw a little bit earlier that one of the other robots, the 5th robot, placed the rear wheel into the rear wheel well. Here's the rear wheel robot, which is about to pick up the wheel for the next car. So I really mainly wanted, and that's the last video I wanted to show. I really wanted to show a lot of videos and not so many images and PowerPoints and simulations. I think it's better to see what is the real world applications and real world installations. I'm going to stop the presentation now. I'd just like to give a few takeaways. So ABB has dedicated teams working on the solutions for the final assembly area. Moving, or the installation of equipment or removal of equipment for moving car bodies is possible. It's working in production series in car plants around the world. And we have a development path for the where we have ongoing investment in R&D to develop new applications. So what we see today is what we have available, but we're working on new additional applications as well. So with that, I would very much encourage people to, if you have any questions, please add them to the chat room down on the bottom. And I'd also be very interested if you would be kind enough to let me know what areas of interest, the applications that you have seen or you would like to see, and just try and give a little bit of feedback. I'd be interested in your feedback about the interest areas. So if anyone has any questions, please feel free to write them in there. Okay, thank you. We have one. For the cockpit mounting robot, what happens when the conveyor has an emergency stop? Okay, so that's a good question. I will go back a little bit and grab one of the videos that we saw previously. So what we have is the camera system, which is mounted on the base of the robot, that is tracking the QR code, gives us with very good accuracy and repeatability the position and the speed of the car body to a much higher precision than we have got using a conveyor, an encoder doing conveyor tracking. What we do is we track the slowdown speed of the conveyor, and we match that slowdown speed with our 7 axes. So the idea is, the concern is obviously if we have an emergency stop on the conveyor and we are putting a cockpit into the position, then the conveyor the robot will stop very quickly, the conveyor will stop more slowly, and we could end up with a collision. So we ramp down the speed of the robot to equally match the ramp down speed of the car. And in this way, we don't have collisions, and the force sensor on the robot gives us a little bit of mechanical compliance, and we don't end up with damaging the product. So thanks very much for that question. if there's any other questions. Again, thank you. Another one. Does ABB have any door unhang solutions for in moving lines? Yes, we do. We do have them for moving lines. I'm not able to show any videos of that, but they are available in moving lines as well, not just on the stop and go or the stationary lines. Okay, so we would be very appreciative if you are able to give some feedback just by scanning this QR code and giving us your comments. Again, we're trying to capture your areas of interest as well as improvements for ourselves for the future. So if you could just take a few minutes to do that, it would be very much appreciated. And it looks like we're not getting any more questions, but if you do have any questions, then please reach out to your local ABB representative and they will pass it on to ourselves and we will contact you and we will help you in the areas that you're interested in. So with that, thank you very much for your time, your attention today, and I hope you've enjoyed this session and the previous sessions as well. Okay, thanks. Bye-bye.